Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In electrophilic aromatic substitution, EAS, specifically nitration, the mechanism involves two key steps. 1. Formation of the nitronium ion, No2+, from mixed acid, and 2. Attack of No2+ on the benzene ring to form a sigma complex, a rhenium ion valent intermediate, followed by loss of a proton, deprotonation, to restore aromaticity. Moving on to the next step. In nitration of benzene by mixed acid, H2SO4 plus HNO3, the slow, rate-determining step is the formation of the sigma complex, attack of No2+ on the ring, not the deprotonation step. The deprotonation step is fast. Moving on to the next step. The kinetic isotope effect, KI, is only observed when the bond to the isotope, H, D, or T, is broken in the rate-determining step. Since CH, or C to D or CT, bond breaking occurs in the fast step, proton loss, not in the rate-determining step, there is no primary kinetic isotope effect on the overall rate of nitration. And for the final step, because the CH-CD-CT bond cleavage is not involved in the rate-determining step, the rates of nitration for C6H6, C6D6, and C6T6 are all equal. There is no observable isotope effect on the reaction rate. Option B, C6H6, C6D6, C6T6 would be correct if CH bond breaking were rate determining, primary KI, but it is not. Option C, C6H6 is equal to C6D6, C6T6 is partially incorrect for the same reason. Option D, C6H6, C6D6, C6T6 is the inverse of KI and is incorrect. Therefore, the correct answer is A. Therefore, the correct answer is option A.